Hello and welcome everyone to this webinar here today. My name is Kevin Schrader. I'm the Technology Evangelist for Zen Technologies. Today we have Daniel Rose here, and he's going to be speaking to us about multi-byte string handling in PHP. There's a bunch of interesting information here, and so I think that you'll get a lot out of this. So with that, I'm going to pass it over to Daniel, and he will talk to you about multi-byte string handling in PHP today. So Daniel, take it away.
Okay, thanks for that, Kevin, and thanks everybody for attending. Yes, I'm going to hopefully give you a very gentle yet complete overview of the mbstring extension. mbstring meaning multibyte, so this is the basic way that we handle multibyte strings in PHP. But what else is it for? Okay, well, multibyte string handling, the clue is in the name. MB means multibyte. Okay, nothing outrageous there. It supports a lot of different character encoding sets. I mean dozens and dozens. A lot of esoteric character sets are actually supported. Importantly, the main flavors of Unicode are all supported as well. We've got some different support for not many, but some different human languages, national languages, if you like. We've got character encoding detection and conversion, which is often useful. And a bit more niche, we've got some, not a lot, but we've got some Japanese-specific functions and settings in the mix as well. I won't cover that in this presentation because it's a little bit esoteric, but certainly, you know, if you're building anything for the Japanese market in PHP, you probably want to have a look at mbstring. So that's what it's for. What it's not, it isn't a way to get the PHP interpreter itself to sort of suddenly magically work internally with, you know, Unicode or what have you. This is or was coming out in PHP 6. I believe it was one of the bigger stumbling blocks for PHP 6. I think it's why we're not on PHP 6 now. So it's not a native support for PHP to internally work on Unicode. That's something you'll have to wait for. But certainly, you know, anything of practical use with multibyte strings, you can use the mbstring extension. Okay, so how do we get this extension? It's a regular extension for PHP. It isn't a built-in extension, but even so, it's often already there in your PHP server, so you'll just more than likely just need to switch it on in your config files and whatnot. In Zen Server, yeah, it's in there out of the box, and it's switched on as well by default. If you don't have the extension in your PHP server, you might need to retrieve it from the appropriate place and then recompile your PHP server. You don't need to compile the actual extension itself. You possibly need to recompile your PHP to, you know, link into the extension. You probably won't need to compile the extension itself. You know, every Windows is different, every Linux is different. I can't, you know, get into supporting every PHP server in this sort of relatively short presentation, but certainly if you're struggling, just have a look at Zen Server and it'll be sort of, you know, you'll be rocking and rolling out of the box with Zen Server. Okay, so hopefully now you've got the extension in your PHP server and it's switched on and everything. Like any other extension, it has some directives, some of which are more useful than others, or more important even. The two key ones I find are these ones here: mbstring.internal encoding, which does what it says it does. It's basically the default character set encoding, not for PHP itself, which we've just talked about, but the default encoding for all of the mbstring functions. A very useful thing to set and design your application around. And then we've got mbstring.language, which is setting the natural language of your application, the human language, if you like. There are lots more directives than these ones here, so if you look at this manual page here, you'll get them all documented quite nicely. Okay, in Zen Server it's very easy for the mbstring extension. In fact, any extension, you get all the settings listed out for you, and you can sort of play with them to your heart's content and just reset the server after you've changed them. A very easy way to learn all the directives there. It'll even list the all the possible options and the defaults for you. Very useful to play with Zen Server if you're kind of trying to learn a new extension. Okay, so hopefully now you know it's switched on. You've set it as you need to. Let's rock and roll. Let's try to use some of the functions that it gives us, of which there are lots. One set of functions that it's giving us is what I call multibyte safe versions of the core string handling functions of PHP. The core string handling functions of PHP, usually starting with str. So, for example, we all know strlen, string length. I hope you would know that anyway. Basically, it's giving you the length of a given string in terms of characters. Well, actually it isn't, which we'll see shortly. So that's string length. Let's have a look at multibyte string length. So here's a little PHP snippet. The extension directives that we talked about just a few slides back, internal encoding and language, you can see at the top here we've just used the general PHP function iniset to set those off right at the top there. For language we've said neutral, and for the internal encoding UTF-8, a Unicode flavor. Okay, greeting, we have a sort of German-looking word here with, if you count, 12 characters in it. But then, okay, let's do a string length on this greeting string. That's giving us 13. So something isn't quite right with that. And what's happening with the regular string length function is that's giving you the count of bytes, basically. That function is working under the assumption that 1 byte is 1 character is 1 byte. Doesn't mean it's broken necessarily, that's just how the function works. It's giving 13 in this case, which for bytes is correct. We know that when we count it, it's actually only 12 characters. So we don't want string length here. If we use MB string length, it gives us 12, which is correct. So the MB functions are working already. They're counting actual characters, be they 1 byte characters, 2 byte characters, or what have you. Okay, we're looking at the same function again here, MB string length. Another snippet. We've set the natural language here to be Japanese, which is one of the allowed settings for that directive. Again, we're on UTF-8, and then we have a greeting string here, which is actually a Japanese piece of text. So let's have a look at string length. That's giving 12. Well, if we look at the string, we can see that that's 4 characters. 12 here is coming from 3 bytes per character. The Japanese language has tens of thousands of different characters, so you're not going to be able to represent those with just 1 byte. You'll need 3, possibly 4 bytes to represent just 1 character. So as far as bytes is concerned, string length is correct. It's not giving us the linguistic count of characters. But then if we look at MB string length, okay, it's working again. It's giving us 4. So yeah, it seems to always be working here. Okay, the last one here for string length. This little snippet here is just to show that with MB string, and especially with Unicode, there's nothing to stop you mixing and matching different natural languages in the same application. So if we set the language directive to neutral, we've got the first greeting, which is Russian. Again, string length is false. I mean, the result is incorrect. MB string length is correct. And then we have a Korean greeting a little bit further down. You can see, again, string length is counting bytes, not characters. So especially with UTF-8, but also with the neutral directive, there's nothing limiting you to, one natural language. That's really the key point of this this little snippet here. Okay, so that was string length. Let's look at one more multi-byte version of a function we probably already know, which is string position. String position is basically giving you the position in a bigger string of a smaller key string. You're finding one small string in a bigger string, basically. So let's have a look at how that works with the regular version versus the multi-byte version. Okay, so language neutral, UTF-8 again. We have a haystack here, which is some Russian characters. A needle, which is what we're looking for, which is this sort of N-looking character. If we do just the regular string position, it's telling us that that needle is 6 characters in the string, which is incorrect. Again, it's working on bytes. 1 byte, 1 character, 1 character, 1 byte. We can just look at that and see that that's not correct. MB string position gives 3, which is correct. And it's actually not massively clear on the slide, but in the haystack string, you can see it starts with a sort of M, and then there's a B and an I. I should say that the B and the I is actually 1 character. It looks like 2, it's actually 1 character. So 3 there is correct. Okay, more string position. This little snippet here is just to show that the MB string functions also work equally correctly with single byte strings. So if you've decided that you need the MB string functions in your application, you don't really need to think, oh, well, in this case it's going to be single byte, so I can just use a regular PHP string function. Okay, this case is going to be multi-byte, so let's use a multi-byte function. You can just use multi-byte functions, the whole way through. So let's have a look at this one, where UTF-8 again, language neutral, and then we have a haystack here. Oh, hi guys, what is new? Regular ASCII, single byte characters. The needle is, and then you can see that string position is correct because it's a single byte string, and then MB string position is also correct because it understands single byte strings, just as well as multi-byte strings. Okay, so that's two of the Multibyte versions of functions that we probably already know. The mbstring extension has a lot of these. Not for every regular string function, but for most of them, there's an MB version. If you look at the PHP.net online manual, you'll be able to cross-reference which one has an MB version and which one doesn't. Most of them do. If you're looking for an MB version of a string function and it's not there, most of the time you can use a slightly different function just to sort of get around it. But yeah, the base is that the core functions have an MB string version, have a multi-byte version. So please look at that. Something that's interesting, you saw that with MB string length and MB string position, the function names were different. They had MB at the start. The interface, I didn't mention it at the time, but the interface is the same. The MB string functions, the interface is the same as the regular single byte string function. So what this means is that we can overload the single byte functions to actually call the multi-byte functions. How you do this is with one of the MB string directives, which is func overload. And you can say, okay, I want you to overload all the string functions. So then if you call string length, it's actually going to call MB string length. So that's possible and quite powerful. I think if you're sort of bridging up a legacy application to make it more kind of future-proof, more kind of localized and internationalized, I think this function overloading can really help you with that. Just beware that you'll have a line in your code that says string position, but actually it's calling MB string position. And then it just sort of ties the code that you write more to the server context. If you migrate that application to another server and you forget this setting, it could all go horribly wrong. In my case, certainly I think if you're writing a brand new PHP application from scratch, I would recommend just to call the MB functions explicitly, and then there's no confusion. But obviously, this function overload directive is an option that's available to you. It's powerful, but be careful is how I would summarize that. Okay, so that was a couple of MB safe versions of sort of pre-existing functions that we already know about. Let's have a look at some more specific things to the MB string extension. Let's look at character encoding. We have a lot of supported encodings. I think I mentioned this earlier. There are, an awful lot of supported encodings. I don't think you'll find what you're looking for, I think, definitely. So we can detect different character encodings. We can convert between different character encodings. Let's look at detect first, because there's a bit of a gotcha, a bit of a catch. Okay, so the function is MB detect encoding. Let's have a look at that. Okay, a little code snippet here. This actually shows a different way to set the extension directives, you notice we're not using iniset anymore. mbstring actually gives us some specific functions to set its own internal directives, which possibly might be better to use than iniset. So you can see here we're using Japanese. Detect order, I'll get more into this later. It's set to automatic here, okay? And then internal encoding UTF-8 again. So what we're doing here is we're just basically downloading some home pages from some different Japanese websites, and then we're doing a detect encoding on the source of that home page. So Rakuten.co.jp, which is a sort of shopping mall, sort of like a Japanese Amazon, I guess. The encoding is giving you EUCJP, which is a sort of Unix-style character encoding for Japanese. Yahoo Japan is giving us UTF-8, which we know already. Nifty.com is giving SGIS, which means ShiftGIS, which is a sort of Microsofty character set for Japanese. And if you actually go to these sites and you do a view source, you can see that MB detect encoding, it's giving the correct character encoding basically. So it's straightforward. You give it the source string, and it's going to tell you what encoding that string is in. Okay, quite straightforward there, but there's a bit of a sort of catch with this, which is MB detect order. Okay, we had auto. The detect order in the previous slide was auto. And then if we have a look at this one here, the top one for Japanese, if we set Japanese, and then we set the detect order to auto, and then we dump out the detect order, which is basically just a list of character sets, we can see we've got ASCII, GIS, UTF-8, EUC, JP, and ShiftGIS. Okay, the character set detection in the previous slide only worked because the encodings of those particular pages were already in this list. That's basically how that worked. So if we look at the second half here, if I set the language to English, which is another valid setting, and then again the detect order to automatic, it's just giving ASCII and UTF-8. Okay, so for example, in the previous slide, if I hadn't set Japanese, if I'd set English, the character encoding detection wouldn't have worked, simply because the encodings in question weren't in the list. So this list becomes quite important, this detect order list. Okay, let's play with this list, this detect order list. So we are language neutral, and then we set an automatic detect order, which if we dump out is the same as it is for English, which is just to say just ASCII and UTF-8. Okay, so if we do a detect encoding on this, this is a Hong Kong government website here. If I detect the encoding on that, MB detect encoding is failing. It's returning false. It's failing simply because the character set that it's using isn't in our little list of detect order. Okay, that sounds kind of really, doesn't sound very useful, does it? But we can customize the list. this function here, mbDetectOrder, we can just pass in a list of character sets that we would expect to find when we're detecting. So you can see I've expanded it. I've put in the middle Big 5, which is a sort of Chinese character encoding, and EUCCN, which is a Unix style character encoding for Chinese characters. So I've basically extended the list, and then after that, if I detect the encoding again, it works. It doesn't error, it doesn't return false, it's telling us Big 5. So we need to have a sensible detect order. It's possibly a little bit not intuitive, but we need to basically know what kind of character sets we're expecting before we try to detect them. I mean, you could, I suppose, set your detect order to a list of every character set that mbstring supports, but I think why it's not like that is just for performance reasons. It would get a bit silly. It would be sort of trying to calculate each string against each character set. I think that's why it's sort of quite short in its defaults. Okay. Okay, so we're still looking at character encodings. That was detect. So detect works. It just needs this detect order to be set correctly. Let's have a look at converting now, okay? Okay, so another snippet here for you. We're language neutral. In my detect order, I've stuffed in the middle ISO 88598. And what that is an ISO character set for Hebrew character support. Okay? And again, every snippet in this presentation is UTF-8. So we have a string here with some multibyte characters, some Hebrew characters. And okay, let's see what it is just already. mbDetect encoding, mbstring, tells us that it's UTF-8. Okay, that makes sense. So what we can do is we can convert, and the interface is that you give it the string, and then you give it the encoding that you want to convert it to. Okay, in this case the ISO 88598 that I just mentioned. Optionally, you can give it the encoding of the original source string, the from encoding. This is optional. If you don't supply that, what it's going to do is it's going to do an mbDetect encoding internally to sort of figure that out for itself. If you know it, yeah, you can pass it to possibly, speed things up a little bit. Okay, so we're converting to this ISO character set, so we do that, and then we detect the encoding. Yeah, it's worked. Okay, ISO 88598. Okay, more encoding conversion here. We're Japanese for the natural language, an automatic detect order, UTF-8 again. This snippet here is showing you that, and it's not something that I would really recommend for sort of really big files. You can convert the encoding of an entire external file. In this case, we have a great file name here, Japanese data in eucjp.csv. So we can read that in with a file get contents, and then just to sort of double check, we can detect the encoding, and it says that yes, it's actually EUCJP. Okay, so let's convert with MB convert encoding. Again, we give the to encoding first. So we want to go to SGIS, which is an alternative Japanese encoding, and we're encoding away from EUCJP. Okay, again, just to check, after that, we detect it and it says that yes, it's now SGIS, shift GIS, and then we can just, blast the file out, and that's one sort of quick and simple way to convert an entire file. Okay. So that was character set detection and conversion. The only catch with that, with character set is that detect order list. Basically, the character sets that you're expecting need to be in that list, really.
Hey, Daniel, let me stop you just for a second. Would you be able to speak up a little bit? I think some people are asking, saying that's a little bit quiet.
Oh, am I too quiet? Oh, sorry. I must apologize if you can't hear me. Okay. I'll man up a little bit. Okay, so now we're looking at regular expressions on multibyte strings. Regular expressions is a massive, massive topic. It's a very complex topic. There are books and books and books written just about it. This isn't an introduction to regular expressions. This is an introduction to regular expressions on multibyte strings, okay? Because the functions that PHP gives us for regular expressions won't work on some of these character sets that we've been looking at. They'll work on UTF-8, as you can see with the note at the bottom. They'll work absolutely, fine with UTF-8. All you need to do is, for UTF-8, on the preg functions, for example, you just have this little U modifier on the end. Okay. Obviously, we're looking at some more kind of esoteric character encodings. The preg functions won't work on these. So let's have a look at the MB functions that will work on these. Okay. We've got MB ereg, MB ereg match, MB ereg replace, and many, many more. Interestingly, there's another internal mbstring setting that we have to play with here, which is the regex encoding. And I talked about how many weird and wonderful encodings mbstring supports. The supported encodings for regexes is actually not quite as many as that. It's just a select few of those actually that are going to work on your regular expressions. So when you're sort of trying to decide the character set of your application, if you're going to be doing a lot of regular expression work, you might want to look into the supported lists of regexes as well. Okay. Okay, MB ereg. Let's have a look at this little snippet here. We're language neutral, UTF-8, and interestingly, with MB regex encoding, I've noticed that regardless of what you set for, the human language, the internal encoding, or what have you, it seems to always default to EUCJP, which possibly isn't useful for us. So what we can do is we can set it with the MB regex encoding function, and you can see it there. We're setting it in this case to UTF-8, okay? And then we have a string with some sort of fancy characters in it, with some umlauts and some little circles above the letters, okay? Preg match at the sort of normal PHP function for regular expression matching. This little pattern here with the 4 dots the slashes on either side are just to sort of delimit the pattern. The 4 dots here are supposed to match 4 characters. 1 dot is 1 character. Okay, so let's do that, and then you can see. Well, it's only giving us 2 characters. What's going on here? Well, like we saw with the functions at the start, the string length and the string position and so on, it's basically working in bytes. So it's correct. It's giving us 4 bytes, but 4 bytes in this case is only 2 characters. So as far as wanting 4 characters is concerned, it's not working out. Okay. Well, let's use an MB function. ereg. If you're a diehard PHP follower, you'll know that in 5.3, ereg regular expressions have been deprecated in PHP from 5.3. In the mbstring extension, they're very much alive and kicking still, which is possibly something to watch out for. And that's why we don't have slashes on this pattern, because it's a sort of slightly different format for regular expressions. But okay, MB ereg and then 4 dots to match 4 characters, and then if we dump that out, yeah, it's worked. We've got the first 4 characters. So it's counting characters and not bytes, which is what we want. Okay. More MB ereg. Let's have a look at this one. We're language neutral. The regex encoding is UTF-8, and then we have a long string of some Hebrew characters here and some spaces. There are 33 characters in total in that string there. Okay, pregmatchAll, a non-multibyte safe function, and then you can see we have a character class in this regular expression, and the sort of n to x, I'm sure that's not how it's pronounced, n to x is sort of the equivalent of a to z. So it's going to match every Hebrew character it finds. Okay. And when we do that, it says 56. Well, we know that there aren't even 56 characters in the string, so that's not really working. Okay, so we go to an MB function now to see if we get any better results. Something to watch for, there's no direct MB equivalent of pregmatchAll, so you'll have to sort of work around that. What we do here is we're matching space or n to x, so space or any Hebrew character, and we're matching as many of those as we can get, and when we do that, we get 33, which is the correct count of characters in the string. Okay. Right, okay, that's the end of looking at mbstring functions. We've got some more stuff coming up. That was a very sort of whistle-stop tour of the sort of key bits and pieces in the mbstring function set. We saw the directive setting functions. You can use any set as well as or instead of those. I don't know, I think somehow it just looks nicer to use the MB functions to do that, to set the directives at the top. We saw the multibyte versions of regular string functions, the string position and the string length, and you know, there are lots of those, and you can overload them as well, like we talked about. And then regular expression functions, which we've just looked at. Encoding, detection, and conversion. Detection being a little bit tricky in that you have to set up the list, the detect order list. If your source string is in some kind of encoding that isn't in that list, you won't be able to detect it, unfortunately. There are some Japanese-specific functions and settings in there. I won't sort of talk about those too much. And some other sort of bits and pieces as well. Quite a lot in there, really. So that was the PHP side of things. That was mbstring. Obviously, in your web application, PHP is just one component of the application. Don't forget your PHP script files, the files themselves. I've found that it's best and it makes sense if you, so for example, if you set the mbstring.internal encoding to UTF-8, I find it's really better to have the file itself saved as UTF-8. Okay. And then there's probably your database, your output, usually HTML, your input, usually form submissions. Let's have a look at some of these other things now. Okay, multibyting your database. Oracle, I haven't touched it for quite a while. What you want to look at is the nchar data type as opposed to the char data type. N stands for national language, so if you set a column to be char 80, for example, it's going to be 80 bytes. If you set it to be nchar 80, it's going to be 80 characters. So nchar is what you're looking for there. Postgres, I haven't used it for a while. Postgres is pretty good at automatically converting input and output character encodings between the client and the server. So it might sort of automatically play out for you. If not, I'm sure there's a way to sort of hard set the input and output character encodings. Again, I'm not really an expert. MySQL, which is something I'm more familiar with, what we want to do here is to choose a collation. You can have a collation on the server, the whole server, each schema, each table, each column. And what a collation means is it's a character set plus a sort order. So if your sort order is, for example, English CS, that would mean English language case sensitive. MySQL has quite a few character sets, and each character set has a few different collations with it. So case sensitive or case insensitive and so on. Okay, again on MySQL, I find it easier to sort of have pretty much everything in your database on one of these two collations, UTF-8 Unicode CI or UTF-8 General CI, which are actually different collations. One is better than the other for sorting different languages. The other one is faster. I must admit, I don't know off the top of my head which one is which. There's a great thread here on the MySQL forum talking about which one's better for what and so on. So you basically need to research and choose the most appropriate collation. And then back into the PHP side of things, after you've connected to your database, but before you start really sort of reading and writing the data, what you want to do is to do one of these two bits of SQL here. So if not your collation, but if your character set is UTF-8, you need to do set names UTF-8, or possibly set character set UTF-8, which is the character set of the collation, not the collation, if you see what I mean there. A very small thing, that was a big stumbling block for me when I first started doing, mbstring apps. because if you don't do that, you won't really get any errors or anything. It's just that your data is going to be garbled when it goes into the database. And it won't error, so that can be messy. So please make sure that's in the mix as well. Okay, multibyting the output, which is usually HTML. So for example, for UTF-8, we need an HTTP header, which is the content type header, which you can see there. Instead of that, or as well as that, you can do HTTP equiv meta header in the actual HTML markup, which is like that there. HTML5 makes it a bit easier, just meta char set UTF-8. Something else to think about with sort of multilingual applications is the language attribute, or if it's XHTML, the XML-lang attribute. Typically this is set on the HTML element. So you can just, for HTML5, for example, you can have HTML lang equals N for English, or lang equals JA for Japanese. Okay. Multibyting your input. It's possible but unusual to have a form, an HTML form, with a different encoding to its host page. I've never seen it. I don't think it would make a lot of sense, but there you have it. Should you need to do that, you could. Out of the box, I've tried to get this to fail. I haven't ever had it fail. As I see it, if you have for example, if your encoding is SGIS and you have a form on that page, and then you submit the form, the data is SGIS. It seems to pick up whatever the host page encoding is. That's always been the case for me. Perhaps I've just been very lucky. It's never not worked for me, but there is a directive which you can look at if you're struggling with this, which is HTTP input. You can force every input to come in as UTF-8 or whatever. You can override it, basically. Okay, that's all. Some last-minute thoughts. We looked at encoding, conversion, and detection. We saw that it was a little bit awkward with that detect order list. Another PHP extension, which is actually a separate thing on its own. It's a operating system library. Icons might be better for you if you're sort of detecting and changing encodings. It might not, but it's a different way to do encoding conversion with PHP, so you might want to look at that as well. Yeah, I mentioned this pregmatch, which isn't an mbstring function. It actually does work with UTF-8, so that's something to keep in mind as well. Okay, there isn't an MB version of trim or pregmatch all, or actually fgetcsv. Not every sort of string-ish function will have an MB version. So don't, it's possible that your favorite function doesn't have an MB string equivalent, and that you might have to sort of work around it with different MB functions, or you might have to actually sort of write your own function to do that. Not everything is covered. Okay, that's the end of it. I think we're going to do questions and answers now, aren't we, Kevin?
Yeah, thank you very much, Daniel. We have a couple of questions here. The first question is, does mbstring support the Indian languages, or the Indian languages?
I presume so. I don't have the full list of character encodings in front of me that it supports. It's a good question. I don't immediately know the answer. If you go to the php.net page and you look at the mbstring docs, there's a list of every supported encoding, and I would hope that the Indian languages are in there as well. Yeah.
I also think, too, that if you're using UTF-8 and using the Indian code pages in there, that just simply using Unicode and UTF-8 will probably handle a lot of that stuff for you.
For sure, if you're sort of building an app that uses different Indian languages, and you see that those character sets aren't supported in mbstring, what you might like to think about doing is just having the thing in UTF-8, which is going to work with any language anyway. And of course, mbstring works very well with UTF-8. So yeah, that would be one way to action that.
All right, another question that we have here, why does mbstring use ereg regular expressions? Haven't they been deprecated from PHP 5.3?
Yes, they have been deprecated. Obviously, the mbstring functions are their own little functions. It's its own code base. Yeah, that's a good question. I don't really know what's going to happen with that. It might be that the MB ereg functions sort of move away and make way for MB, preg functions. They might sort of rewrite it all in preg to match, the core PHP. It's a good question, and I'm not too sure. I think the thing to keep in mind is, at least for the time being, the MB regular expression patterns are going to be a bit different. That's all.
Right. What's the difference between a character set and a collation?
Okay, yes. Well, a collation includes a character set, sure, and a collation is a character set and an order of sorting in SQL. So, if you've got a string field in your database, like somebody's first name or something, and you do order by first name ask, order ascending, how that's going to get sorted is based on collation. So if you have a lot of, let's say, German names in there with umlauts and things, if you have the right collation, they're going to get sorted, according to, German linguistic rules with the umlauts and things. If you have just a bog standard sort of English collation, it's probably going to ignore the umlaut and just sort it as, an O or an A or whatever. I would describe collation as a sorting order for, different alphabets of the world, really.
All right. Next question is, on a UTF-8 only website or application, header set to UTF-8 and the database set to UTF-8, would you recommend using the function overloading?
Okay. So the database is UTF-8 and what was UTF-8? The database and the...
Database and the website.
Okay. It's... You could do, yeah. It's... I mean, if it's both in if they're both in UTF-8, it's, I don't know, it's possibly been using MB functions from the start. Yeah, that's possible. You could set function overloading and then you can use the regular string functions and it'll all sort of play out quite nicely. The only thing that I can think being a sort of gotcha there is the set names UTF-8 thing that we mentioned for the MySQL database. Function overloading would work for any supported character encoding of mbstring. So yeah, should you need or want to do that, yeah, you could do that.
All right, and we have time for one more question. When one character, actually, there's no one that came in. When one character equals 1 byte, I can access individual characters of a string by treating the string as an array and using an offset. For example, using string open and close brackets 3 to get the 4th character. How would this work with multi-byte strings?
Good question. Yeah, that's right. A single byte string in PHP is actually an array of characters. Some people don't realize this. If you have a string, hello, you can access it as a sort of array, and the array index is the offset of the character in the string. I'm guessing that wouldn't work with a multi-byte string. Please try it. I'll be very surprised if it does work. How I would get around that with a multi-byte sort of context is, you would have to split the string into single characters, possibly using some kind of regular expression splitter. You could split it on nothing, and then you have an actual array of characters, not just a sort of implicit array of bytes. Possibly explode or something like this might work, just to split it into actual characters. You would basically have to use some kind of function to get a real array of characters from the multi-byte string. Yeah.
All right, well, that brings us to the bottom of the hour, and we are basically out of time, so I would like to thank everybody here for showing up. Lots of good information here that we got on working with multi-byte character strings. Just a quick reminder: we will have the webinar. Excuse me. We will have the webinar up on our website in a couple of days, and we will try and post that on Facebook to let you know when that actually occurs. And just a final note again: remember, we have got ZenCon, the Zen PHP conference, coming up this year in October, towards the end of October, in Santa Clara, California. So thank you for joining us, and we will see you again in another Zen webinar.